Hello everyone, thanks so much for joining us today for the webinar called Steal with Pride, Learn from the Mistakes and Catastrophes of Others. My name is Jack Tretui and I am the Outreach Coordinator for the IMechE Yorkshire Humber Processes Division. And our speaker for today is John Bartlett. John has worked in various industries including chemical, nuclear and naval engineering industries. He has experience as a designer and developer, project manager, regulatory assessor, inspector, and safety reviewer. We'll also be joined by Richard Roff and Malcolm Starstead later in the presentation for a Q&A session at the end. So we strongly encourage you throughout the presentation to submit your questions as and when they come to you. I'd also just like to take this opportunity to make you aware of a new booklet that's been released that has been prepared to identify the information, training, and skill set necessary to pursue a career in the oil, gas and chemical industry as a mechanical engineer, designed for students and graduates alike. And it's a PDF and is available to view on the IMechE Yorkshire Humber Process Industries website. So without further ado, I shall pass you over to our speaker for this event. Thanks, and again, please do feel free to submit your questions throughout. Thank you.
Thank you, Jack. Good morning, everybody. My name is John Bartlett, and today, welcome to this second webinar in our mini-series. I hope to give you some examples of relevance from other industries than the chemical industry, going from decades past to just last week. It's in two parts, which is the presentation by me, and the second is the panel discussion with Richard and Malcolm and myself. Now, is PSM, Process Safety Management, for you? Why bother yourselves, as the slide says, with process safety and its management? We are, after all, mechanical manufacturing engineers, not chemical process engineers. What we want to implant is the thought and the reaction, if you pardon the pun, that process engineering is not chemical engineering only. It needs to be seen in a much wider view as manufacturing engineering, from raw materials through to final disposal. And process safety is relevant and very important at all the stages, not only if it's relevant, if it's this sort of reaction, the chemical reaction at the start. Now, the background for me, this is being a little bit slow, I'm afraid, is I'm a member of the Greater North West Centre, and we have somewhere up to 20,000 people involved in the process industries. I've worked in, for example, fast breeder reactors, chemical reprocessing plant, pressure vessels, saturation diving systems, bells and chambers, hovercraft and submarine propulsion. We try to reveal to students and pupils locally just how wide and varied the process industries are, especially in the Northwest. It's the variety that we can get in the process industries if you look for it, more to the point, if you know about it. Engineering at all times. The approach to process safety management is applicable to the design of procedures and to plant, and the world of engineering is complex. It is our contention on the North West Centre Committee that mechanical and electrical engineers tend to be brought in a bit too late at a stage of design development or layout. We need to be brought in at the conceptual design stage, and we need to be able to help people distinguish between what may be seen in Has-an or even Has-id as minor events and point out the possible stages that could lead from minor through major to a catastrophe. Now, to help that, and this is not a simple matter of detailed design, and the possibility does still exist that these minor events will go far worse, to help to distinguish between the various stages, I refer you to the ASME, the American Society of Mechanical Engineers, Boiler and Pressure Vessel Code, particularly the nuclear part, where it has 4 levels of design and conditions or states, each of which is addressed separately with design specs and design reports. And those are normal, upset, fault, and emergency. If you think in those terms, it helps you to get things in perspective, but it also helps you to go back in the plan or the plot to find out why you're being asked to do something in this particular order. And you may well be able to challenge it then. Now, this might sound like a bid for world domination, but it is not. Well, not a lot anyway. It's an appeal for greater recognition of our manufacturing engineers' obviously underappreciated skills and usefulness. Also, process safety management is much more than occupational safety, which is how many people tend to view it. At one end you have the process safety of the chemical reactions, and at the other you have the occupational and health and safety practitioners, and somewhere in between are the people who make the plant work, design it, build it, put in various obstacles to the progression of minor faults into major. And it is those people that have certainly a key role, and it's those people that can help put barriers in place to the development. I'll try to provide ideas and sources and examples for us to use as individual engineers and technologists. Richard Roff, in his presentation of the 20th of May, presented the the business and company approaches that can be taken. In this, I concentrate on providing ideas for individual engineers. So, what do? Well, keep an eye open. Almost always, your plant has been designed somewhere or other, operated somewhere or other, already, possibly for years and years and years. Mistakes have been made. You should look out for these, and that's a deliberate act to, in some way, interrogate the company database, the corporate database. The trick is to keep aware of it. To be aware of it, but keep aware of it despite the huge amount. There was, for example, an explosion just 2 weeks ago at the Chem Tool site in Rockton in Illinois, and it was on the 15th of June. Manufacturer of petroleum-based lubricants, and it was a fairly simple thing that went wrong. And yet, it was not a chemical thing that went wrong, but it led to quite a bad explosion and fire, possibly fatal. Funnily enough, there was another one just before that. April the 8th in this instance, a paints and polymers plant, again in North America, in Ohio. Fatal, just one killed, but it was steam or gas heated kettles that were used to condition resins. It's fairly well known stuff, but suddenly we have an explosion and a fire, deaths. There were 21 people on plant. Luckily only one was killed. These things keep on occurring. Despite all the design reports, the evidence, even seminars and so on, they shouldn't be, but they do. Where to look? Where could I start? There are many, many, many reports on HSE's website of incidents and prosecutions. Wikipedia is a really, really good source of these things. On the 20th of May, Richard listed dozens of examples of catastrophes. He grouped them into 6 distinct groups, and there were nearly 70 of these things, and none of them were that old. That's an awful lot of precedents and info that you could dip into. And that's regardless of your corporate memory bank, but you do need somebody who either knew it happened, hence the seminars and this sort of webinar, or somebody who was there and can really, really help you. Another thing you could do is attend our seminars and webinars. The most popular are those that deal with other people's catastrophes. They are always in the dozens and dozens of attendees in person, or those about new regulations. Here we are, leadership principles for process safety management. These are available from the HSE website, the Cogent Skills website. There were any number of people, associations involved, and they're easy enough to find. It's a busy slide, and I've underlined the bits that are the points I would like to make. Good process safety management does not happen by chance. It requires our active engagement. It requires the engagement of the workforce at whatever level, not just the designers in the office who are doing perhaps a conceptual and a development design, but also the people that either will operate it or have operated it, and somewhere in between. There's an awful lot of info that you can tap into. You can't spend your own time doing it, but you can tap into the written sources, and you should. Finally, on this slide, sharing best practice, which is what we're about here. That's across industry sectors. Some of them don't seem at all relevant at times. And learning and implementing lessons from relevant incidents. This is learning from experience. It is important. And if you don't do it, I think you'd be pulled up about it should you ever have to appear in court. There we are. That's the next one. You need to engineer these things early. You might be thinking, as I've said on the slide, you've got enough on your plate to clear the processing swamp. So if you do get into problems or you do wonder why, try and go back to the HAS IDs. These are a rather neglected area in not a few organisations because people think they know all about it. The plant's been operated safely for the whole of 10 years. It operated safely last year. What's going to change? So before you go into the HASANs, and HASANs are tedious, I know, you should have a look at the HAS IDs, see if they've got your part of ship, as we say, your bits of expertise, your piping, your vessels, your ventilation covered in, shall we say, decent detail, rather than the bog standard detail of having got brackets and so on. Where's this pipe going? What's it being subjected to? Think about the project or the plant as an end-to-end scheme for handling and processing. An example was reloading nuclear fuel into a submarine in the dockyard, and you can view it as a set of facilities: the docking down facility, the ion exchange processing facility. What we suggested was that you treat it as a spent nuclear fuel handling process, where you ship it in wrapped in a submarine, you open the reactor and drag it out, you then shield it, you then send it for processing. And if you do it in that way, you are keeping your eye on the main hazard, and you can look in detail separately at the risks of that hazard. For example, the submarine being swamped in the dock, a tug taking it out. It does help to take a good big step back and wonder what it is you're being asked to do. So you should challenge the why and the how. Not just the what, but the why and the how. To help you with the work that you're doing, we have, one too far. We have the risks and the laws surrounding what you're doing. You need to understand the risks of your project, obviously. You can't understand them all, but there are people that can help within the organisation, and you should be sensible enough to be able to apply it. Safety and risk management, after all, are everybody's business. Have you done all of these reasons practicable to remove, or at least to minimize the hazard? and the risk that it's subject to. If not, and you do appear in court, you'll be asked why not. It's very easy for lawyers to say, well, why did you not take an hour just to look into it? Well, you've got a lot of other things going on. Unfortunately, or fortunately, I think it's a very good act. You've got the Health and Safety at Work Act to chase you, the EU six-pack of regulations, you've got COMA and OSHA and a variety of other bits of legislation. Most of it's criminal, some is civil. If you don't know that they exist, and not many people are that familiar, it is time that you did, and you can find out just how exposed you are to the challenge of not being professional enough, whether you're mechanical, electrical, chemical, civil, or whatever the discipline. A LARP is a real driver for improvements in process safety. It's not peculiar to the English and Welsh law, the UK law, but it is not that well understood abroad, where prescriptive legislation or regulation is, or has been, the norm. Goal setting is the opposite of prescription, and whoops, there we are. Yes, goal setting is really useful because you can help by taking your step back and then decide what it is overall that you in your part of the plant is trying to achieve. It's very woolly, and at times as a regulator you feel like you're the shepherd trying to herd cats. Engineers are quite individualistic, and they are precious about their discipline, which is a good thing, but not always. Now, while you're doing all of this and worrying yourself to death, here are some other things to worry about. The EA in this country is considering linking the net zero target of the government and the climate changes that are being sought to the has-an of extreme events such as wind, temperature and coastal flooding. Fukushima is a good example of what can go wrong, and there was a huge tidal overtopping of the barrier walls. New legislation is on its way, apparently, with a view to placing a requirement on regulators to influence companies. That sounds a bit prescriptive, does it not? Cogent skills, as I say on the slide, under Richard Roff, is a useful pan-process industry source of what is going on. That's where I got those 2 points from. Other places to learn? There are many, as I've said, there are dozens and dozens. One of them, and this is a puff for the safety and reliability group in IMechE, that they have one on human factors play a key role, as you can read, in productivity, reliability and efficiency in engineering practice. It could well help us to learn more about our own ways of working. It will have more studies and examples, which are always welcome, as long as they're relevant, of course. Now, you're perhaps wondering, does this apply to me? Am I a process industry? Well, after much woolly thought and deep consideration, we decided that process industries include the water, read it for yourselves, the water and the utilities, food and pharmaceuticals, mechanical handling, nuclear fuels manufacture, and all stages from conceptual designs to decommissioning. And in the Northwest especially, we've got almost every one of these, from baked beans, bakeries, to nuclear fuel, manufacture and processing, submarine building, processing equipment building, all sorts of things. Not very long ago, there was, I think it's a wood chip handling or manufacturing plant at Bosley near Macclesfield, and that blew up, and that's just been reported on. We make munitions too. More unwanted events from the chemical industries in this case. There is the plant that the plant didn't explode, but a blower did, and luckily the guard that was there to stop you putting your hands in to make it process operator proof, luckily stopped the fragmentation bits from going too far. Luckily there was nobody around. But in this case, the American IMechE Center for Chemical Process Safety in the USA published a sheet on the hidden chains of hazards, which is available, and it's under their Process Safety Beacon publications. They published a sheet on this, and it was a restart of plant problem, been done a few times before, but the pulley on the blower of a mist separator broke suddenly whilst rotating, and the explosive fragments were captured, which is a good thing. It was a check valve that had filled with water. There was no way of checking the check valve for whether it operated or not. Usually it was under a water seal. It wasn't a chemical fault. It was a simple and well understood process, but something went wrong in the mechanical bits. In this case, could have killed somebody. Luckily it didn't. Now this is relatively simple, but you've got other more complicated ones which have also simple bits and pieces in the chain of events. Surveysold, Flixborough, Sellafield, Bhopal, Camelford, and these are quite old ones. Understanding incidents. The Process Safety Forum is a very good source of information and opinion. They published one of their learning briefs, number 022, and this is addressing COVID-19 risks. It's thought, and this was a styrene link from the LG polymers plant in Visakhapatnam, and it was caused by failures in restart. People didn't do what was required, partly because there just weren't enough people. They were on COVID furlough, shall we say. Two chemical tanks, they've been left unattended since March, and we're looking now at May, only, 2 months, and a full investigation is yet to be completed, but a gas valve malfunction, just a gas valve. Again, was it not inspected? Should it have been? Was it recognised? It went, and it looks like something like COVID-related disruption. This is one of the barriers of the Swiss cheese model. There are four, broadly speaking, four kinds of barrier: organisational influences, supervision, preconditions, and specific acts. And this looks like a precondition for failure. Not enough people. Did they think of that in the HAZAN and the HAZID? It led to holes in safety controls. If you want to follow up the Swiss cheese model, it was devised by James Reason of the University of Manchester. It's also called the Cumulative Act Effect. And that, again, is where we come in, our little bits and pieces of omission and commission. There on the right are the four types of barrier. It's not at all an easy read, is this slide, but you can see the principle that you have the various barriers to mitigate whatever is going wrong and to prevent it becoming much worse. Oops. There we are. It's a very difficult thing to define as process safety. I've tried elsewhere. I've been helped, but only by means of, here are our ideas on process safety leadership or process safety management. This is the best I've come up with. Again, it's from America. process safety is a major accidents prevention. I think we could all agree with that. To my mind, it's not only major hazards containment, although if that worked perfectly, there wouldn't be any releases and toxic gases going out, but then you would never be able to shift the stuff. Industry success is seen as new or modified standards and practices. We get them, but usually after the event. Instrumentation, mechanical integrity, operator procedures, management systems, not dissimilar from the four broad barriers of the Swiss cheese model. It is, in short, major accident prevention, hazard containment, and that containment happens at many stages through the design, manufacture, fabrication, etc., all the way to and including decommissioning. It's also appropriate to the risks in minimizing the intermediate hazards and states of things like, and I hate to mention this, containment of spoil heaps like Aberfan, tailings, dam failures, liquors. There were small leaks at Sellafield. One of them began with a fillet weld. There's more of that later. Some thoughts from elsewhere. Well, I've just missed a bit. If I go back one, beg your pardon. Those words are taken from this lady, a senior chemical engineer with many years of experience, and she gave this presentation, of which that is a part, to the young members session of the IMechE in America. She's a president of another company. The president made the point that process safety is the responsibility of everyone, not one department. Management should change. You need to keep the changes under the same duty of examination, care, thoroughness as the original design and build. And it isn't just paperwork, safety cases and so on. And I've heard we have a safety case, so we must be okay. The safety case is for the operators, the owner's use, and not just for the regulator. Note that she mentions specifically mechanical integrity, and that it extends beyond preventive maintenance and testing. There she is, Dr. Angela Summers. Her work is well worth examining further. This is what I've been doing just recently. And she's a chemical engineer. She did say clearly that process safety is a culture, a way of doing business. This is Jennifer Johnson, Professional Engineering last year, headline reports of safety culture in PSM. You need process safety leadership, and you need to be thorough. And you will be involved in the barriers one way or another. Safety, sorry, beg your pardon, safe or reliable, or is it some other state, some other state of complacency? Well, despite alignment of barriers and so on, the HSE found that the focus on avoiding serious accidents had led to some operators offshore to neglect general plant maintenance. This is what other people have found, and there is a balance to be struck. And the processing could be any one of those things. It does not need to be in oil and gas, from tank to disposal. It could be at any one of those stops. And if you don't maintain the thing properly, you don't install it properly, you don't design in detail properly, these things can catch you out. Unfortunately, they catch you out too often, as you can see from the list of 69 items. Here's a big example, Piper Alpha. I was in Glasgow at the time it went off and wondered why there were so many helicopters available. She caught fire in July 1988, 4 main causes, but the Cullen inquiry reported that it was just, sorry, it wasn't just, but they reported that it was a condensate leak and the result of maintenance on a pump and a related safety valve. Nothing to do with downhole this, mud that, giant pipelines and so on, just a bit of maintenance. It's one of those things where the hazard people may not have picked this up, but there's no feedback to encourage them either. It was a perceived or assumed safe state. More recently, well, believe it or not, December last year, I think it was, possibly it was the year before, Bury Alpha, not far from Piper Alpha, was shut down following a gas leak, and it remains shut down. It was a major gas leak. Bit of remote, it was exposed work, and it found that there'd been a failure to remove insulation of pipework. You know of corrosion under insulation, CUI. They'd not done anything in the way of looking at it since it was commissioned in '83. That's nearly 30 years ago. And they'd already been struck with improvement notices on the same platform just last June. So these things happen and happen again. Another example, completely different industry, is Grenfell Tower. That was June of 2017 in London. Again, 4 key findings from the inquiry, but one for us was that the cladding properties were not well known. Why not? You can look them up, etc. But they weren't well known, and despite that, it was largely responsible for the rapid spread of the fire. So the inquiry recommended owners and managers be required to do it, and there was a predecessor. It appears Calcott's estate. Another example is Ronan Point. In this case, it was a progressive collapse. Things have been noticed about it, groaning and so on, but the belief was that building design must be safe if it complied to the regs. Well, Miamidade has just collapsed in Champlain Tower South, and that was a progressive collapse, possibly the same sort of thing, and they'd received thorough engineering inspections over the last few months. Another example, but from a different industry, is the Port Ramsgate walkway. I cannot find a slide for this one, so I took one from a couple of years before, 13 years ago, I should say, and it was the ramp to the F, and that went the same way. It was a link span ramp, and down it went. In this case, the Port Ramsgate case, the collapsed walkway killed 6. It was a matter of calculations not being done properly, and this is either done or checked by 3 different organisations. These things can catch you out. I found a factor of 10 in the decompression chamber's design pressure. They converted it with a factor of 10, but done it twice, so that 30 atmospheres turned out in the design to be only 3 atmospheres. Luckily, the thing was well thick enough. In this case, there was another fillet weld, and this was on the little wheels. There were only 2 of them that allowed the thing to slide to and fro as the railroad ferry moved. And that was it, that took the load. Another horrible example, this case, HMS Glasgow's fire in 1976. They got temperatures of apparently 1300 degrees C. Horrible way to go. And what was it? Well, it was pressurization of the manifolds, which allowed pressurizing of the hoses gently in an oxygen-enriched atmosphere. A LARP, I think, would expect depressurization of the manifolds and hoses. Not a difficult thing to do. What was it in the hazards? Finally, King's Cross. Hello. King's Cross was a rubbish fire in November '87. Rubbish and grease under wooden escalators. This had been identified, I'm pretty sure, but ignored. May '85, the Bradford City fire killed 56 people. Again, rubbish under wooden roofed old stand with wooden seats, probably. Not cleared out. It was allowed to pile up, but it had been noted and then been told they should do something about it. The stand had been condemned and was going to be demolished starting in a matter of weeks after this final match. Poor maintenance, no learning from experience for King's Cross. It does make you wonder, and people will ask, why did you not take any notice? No evacuation plan. There wasn't a plan for Bradford. Conclusions. Take a step back, as I've said. Think about it as a process from beginning to end, not just your little part of piping design or ventilation. Seek out for sure what's been done, especially badly or accidentally, wrongly, beforehand. Be thorough. Have you done as much as is reasonably possible to minimise the risk and hazards? That is the key. It makes you think a bit wider. And then learn those lessons. Steal them with pride. Don't be afraid to pinch their ideas. And that's for your own project and for your own professional protection. My slides have been a bit slow to turn over. I'm sorry about that. But there are the three people for the discussion. And it's over to you, Jack. Thank you.
Great. Thank you very much, John, for that presentation. So now is the time where we will be moving over to the panel discussion. This is where you submit your questions and then they are discussed amongst the three panel members on the slide here. So one question we've got coming in, and if you bear with me because it's quite a meaty question, is what is the best practice for application of as low as reasonably practicable principles to maintenance frequencies for protective devices such as pressure relief valves in the absence of data to support risk calculations? And then he goes on to ask, how can a failure management strategy be judged as meeting as low as reasonably practicable principles? Would anybody like to take that on?
Can I give one short answer, please? The LARP principle requires, has this problem occurred before? Has it been sorted in your industry or in your factories? If not, has it been done elsewhere? If it has, then it's practicable. You then have to judge whether for your company it is reasonably practicable, and only you can do that. I'm sorry, there isn't a short answer for your first question. Sorry, there isn't a good answer for your first one. There's only your conscience and your thoroughness that can sort that. Over.
Okay, thank you very much.
Yeah, I mean, in terms of pressure systems in general, obviously the inspection schemes that are expected for such items, and so that actually is beyond pressure systems, but in general, pressure systems being safety critical systems, the expectation is that you would, as an operator, build up knowledge of how that system operates in your context. So that's a little bit like John's talking about. So, you know, my expectation is that we would set the next inspection some conservative date in the future based on what we know around this setting and similar settings, and then we'd start to build up data. So, you know, pressure systems safety regs require us to set the next inspection based on the data we have so far, and that applies to the piping and the vessels and to the protective devices. So, you know, if you're concerned about blockage, let's say, then in some respects you have to make a conservative start and then see what you find. And if things are not being blocked over the term that you've left it before inspection, then we might choose to extend the term to the next inspection. Strictly, I guess that law has moved away from standard intervals between inspections and moved just towards what does the data tell us the next inspection date ought to be. I hope that makes sense as a response to the question, because it is probably a little while since I was last signing off vessel inspection reports.
Great, thank you very much. We'll move on to another question. This is a probably more holistic question, which is around education and engineers. Is that do you think there should be more training in undergraduate degrees in correct safety practices? Do you think this is something which is often overlooked for in young undergraduate engineers?
Well, so the short answer is yes. The difficulty is trying to work out where to fit it in amongst your syllabuses. I think the situation of trying to create syllabus input that is general enough to consider the huge range of the kinds of tasks that mechanical engineers or electrical engineers might be asked to undertake. But yeah, more the better, and hopefully we're also trying to help with some of the content in terms of the sorts of things we're doing through the institutions. Malcolm, you might want to speak. You're a member of the IET, and you may have a view on the way you've seen engineers coming through that institution.
Yeah, hello. Yeah, Malcolm here. Yeah, I mean, this is a very interesting question. Sort of there is certainly some talk now of sort of, if you like, career-specific, competence. So looking at specifically what people are doing and how they're competent. But I think you're right. It's very difficult to tackle in a university when everyone goes into such diverse, range of activities. So yeah, I personally feel probably something that comes when you start in your industry, and then you get to understand, well, what are the hazards in my industry, and what are the approaches? Yeah, but I think obviously looking at what other people are doing in other industries is relevant. But yeah, it's very difficult, I think, at a university stage. Can I just make a little bit of a comment about the first question? I think it was the as low as reasonably practicable, the LARP. The only thing I would have possibly add is what I've seen in quite a lot of companies is they develop, if you like, what you might call a risk matrix. So you'd maybe have on the y-axis, you'd have a range from a minor, minor injury or minor accident to a serious, to a major, to a critical, to a catastrophic, something like that on the severity. And then you would have on the x-axis a range of likelihoods, probabilities. And of course, and what you'll find when you have this matrix is you'll have if you like, in one corner might be the bottom left corner, you'll have a region that you say is broadly acceptable as tolerable. So in other words, the severity is balanced by the likelihood, very unlikely. And that's the range where we'd say it's a tolerable risk. And then in the top right corner, maybe you've got a region where you would regard it as an intolerable risk. And then sat in the middle is this, you sometimes colored in yellow, is this yellow band of what we would broadly call, it's tolerable if it's as low as reasonably practicable. And then, yeah, you would take John's point, like, well, has it been done elsewhere before, and that. And that's where you balance the cost and difficulty against the reduction in safety, So, it might be very expensive to implement, and is the reduction, relevant? So I think the risk matrix is probably one of the best ways of looking at the LARP thing.
Great, thank you. Just in addition to that, we've had a comment from the audience saying that there is actually an ALARP best practice guidance document produced by the IMechE Safety and Reliability Group. Just that may help answer the first question. So that's just a bit of knowledge for anybody in the audience who's curious about that. This is more of a statement than a fact, but it might be quite useful. Is that so this is an audience member who's commented that they highly recommend the European Process Safety Centre. They run free webinars and produce monthly learning sheets based on actual PSCs. They've also analysed 908 PSCs reported in Europe in 2019 and have used the analysis to produce process safety fundamentals. They've also shared a link which could probably be shared around with the audience at the end of the webinar. So thank you very much to the person who commented.
Sorry, mate. I absolutely concur with that. As I was a member of the IPSC when I worked in the steel industry. So they have a kind of wider viewpoint across European process safety. So yes, I agree with that.
Brilliant. Right, so we'll go on to another question. So this is probably best directed at John for now, but can be expanded into the wider discussion in a bit. Is that when you say that the engagement of workforce is needed for good leadership skills in safety practices, can you give some practical examples of how this can be applied?
Yes, starting with the simple Toolbox Talks, where shall we call them the latest ideas for improving safety are passed forward, but the people who are receiving this can give feedback as to what is going wrong, what could go wrong. That is one of them. The encouragement of buying companies for people to join various committees and even to attend inquiries is one way of keeping in touch with the wider world, as long as, of course, they report it to the company and disseminate it. I've worked for companies where you have formal groupings of process engineer, chemicals, mechanical, civil, structural engineers, and that was a successful, limited but successful way of spreading the word about process safety or safety in general, and not just occupational safety. But there are other ways, some of them like the IMechE, the IMechE, which are volunteer things, and there are some where your company can join under the COMA scheme, that sort of thing. Beyond that, though, it's as wide and as deep as you wish to make it for finding out what is happening, what's going wrong, and what you can do about it. HSC's website is a very good source of that sort of thing. Bit windy, but...
Great, thank you.
Sorry.
That's okay, go on, sorry.
No, that was it. I can't give you any more.
Oh, right, okay.
That without being
Rich and Malcolm, do you have anything to add?
Yeah, Malcolm here. Yeah. I would add something. So this is something, I'm in the consumer goods industry, and this is something we struggled a bit with, if you like, also with, if you like, senior leaders who wouldn't necessarily be engineers by training or background. How do you make sort of process safety visible and thereby sort of engage people? And one of the techniques that we've been doing is really a build on something that John mentioned. John mentioned the James Reason Swiss cheese model, but actually there is a tool known as the bow tie tool, which is really a build on the James Reason approach, where in essence in the bow tie it's a very simple diagram to understand and to follow, but you start off by identifying, well, what could go wrong, if you like. Now that sounds obvious, but it's not as obvious as it sounds, really. These incidents often prove that people didn't really know what could go wrong, but you start off with what could go wrong, and then you say, well, okay, so, and what are the things that can cause this thing to go wrong? And then you go to, well, what are the barriers that prevent that from happening? And then finally, you would go on the other side of the bow tie and look at, well, if it did happen, what are the barriers that would, if you like, mitigate the consequence? And we found this bow tie tool, it's very visual, and it's a lot more easy for senior leaders to, if you like, be able to confidently say, I know what can go wrong on my facility. I know what the barriers are that are in place to prevent that. And by the way, I go out on the plant and I check that those barriers are effective and working. So I know that the controls are working, or I have KPIs that tell me the controls are working. So we found the bow tie is very, very visual and it's been a great help to kind of widen the understanding of process safety amongst people who are perhaps not trained engineers by background. I think this started where, initially, of course, everyone talks about HAZOP studies, etc. But for somebody that's not technical, something like a HAZOP is very difficult to understand and interpret. But something like a bow tie diagram makes it very visual, very easy for people. So I think that's one of the things we've done to try and improve the sort of awareness and engagement in process safety, and thereby engage the whole workforce, because everyone can quite quickly understand bow ties.
Great. Okay. Thank you very much. So going back to the question we had earlier about undergraduates, there's another question which has come through, which is, so this person says that what we find is that a lot of graduate engineers, when they join the workforce, are scared and lack confidence to ask for help or advice, and genuinely try to do things on their own to ensure that people, so their managers or supervisors, don't think they're not good at the job. So can a mechanism be introduced at university level to instill the attitude that it is okay not to know everything and seeking advice is a sign of strength? So this is probably getting away from the subject of the webinar, but I still think it's quite a good and relevant question.
Okay, Jack, I'll take that for a start. it is a very valid observation that sometimes psychological safety doesn't exist, and actually it doesn't just apply to junior engineers and recent graduates. It applies right the way through organisations, in my experience. So it's kind of incumbent on organisations that employ engineers to make it so that it's acceptable for particularly junior staff to say, I don't know this, please help me out. Whether or not that's a thing that can be taught at university or placed into university syllabus, I'm not sure. I think it's absolutely a vital role for the institutions to instill that being a professional means saying I don't know a thing if you don't know a thing. It's part of certainly the mechanical and engineering institutions' professionalism standards, and it really does form part of the Engineering Council's approach as well. So good point. Not sure whether it's a university question or whether it's an institution question. But for me, it's also an organisational question, because people have to be rendered in a place where where it's acceptable to learn and to admit you don't know everything. The organisations that do that well seem to be better places to work, as well as have better outcomes in the sort of safety, health, and environmental protection world. Other thoughts from others?
Jack, may I add?
Right. Okay. Yeah. Very well put. Sorry.
May I add something to that? For undergraduate training, I was lucky to do a thin sandwich course with ICI, where half the year was spent on plant workshops and so on. And I went in as a green 18-year-old A-level student and came out as a dirty-handed practitioner of a kind of engineering. I believe that sort of apprenticeship, and it might be what forms the basis of degree apprenticeships now, is essential to combat the lack of confidence and not knowing what you're talking about, being afraid to ask, because you've made some mistakes during your apprenticeship. I did. And B, it helps to round you out. So not a lot, because you're still young and know it all. It helps you to round it out why you're being taught, what you're being taught in the way of mechanics, human factors, ergonomics, chemistry, and all the rest of it. But I do like the thin sandwich courses. Thanks.
Thank you. And right, we will move on to what currently I believe is the final question of the webinar. And again, it's quite a vague one, so you might struggle to answer it, but I'll ask it anyways. What proportion of accidents in general do you believe are down to lack of employee training or even carelessness?
Okay, so I would regard carelessness and lack of training as two entirely different subject areas. As first thing, what proportion? Good question. If we took training as a specific, I'm not sure it's a very high proportion. If we took poor communications as a more general aspect, which includes training and transmitting information, then maybe as many as 40%, but things changing is often one of the preconditions in my own experience, and I have to say that's just my own experience and not a more general subject. Now, when we kind of use the term carelessness, we have to be a little bit careful about what we mean there. If we mean that I have perhaps taken a shortcut in my work because I thought it was more efficient, or because everyone takes the same shortcut, then would we regard that as carelessness? I think it's worth looking for more information in this area on the human error model, also one of James' reasons. But the human error model kind of defines the way people's behaviours diverge from what was required in different ways from perhaps what our common language would use. I personally don't like the idea of carelessness certainly in the context of investigations, because it's charged language, but it also doesn't really help us out with what to do next. So that's an opinion and a couple of vague statements about proportions. I hope that helps.
Jack, may I? Going to the point of carelessness, we are expected from our experience to design out hazards and risks. We can't do them all because we don't know them all, but we do try with naval stuff to make the kit sailor-proof. And in general, and especially in chemical and manufacturing plants, we try to make it man-proof. An example, there are people like me who try and beat the lathe I'm working on by switching it on and pulling out the T-bar. Ha! I didn't, and it flew past my head. There are other people who take the risks. I'll just step round this thing. I can't be bothered using the ladders. I'm a bloke. I know what I'm doing. One poor fella fell 200 odd feet. He's certainly dead. So there are two parts, and that carelessness is not just careless. It is deliberate acts of I don't know what you call them, to be honest. You can design out people falling asleep. We used to have, I think it was a soap boiler pan, big one, several meters across, and the guy watching it, so it didn't boil over, would sit down and lean on the pan, which he could do, but he was given a two-legged or a one-legged stool, so if he did fall asleep, he would fall over, and you could sort of design out the risk. But carelessness is always there, especially with blokes around.
Malcolm here. Yeah, Malcolm here. I brought to mind something else that's kind of cropped up from when you do a so-called root cause analysis of an incident. So I think everyone's probably come across this where you repeatedly ask why. So you initially flush out, if you like, the direct causes of the incident, and then you get to the root causes. But often the root of the root causes is the organization's culture. So what the organization accepts is what happens. So, you've really got to work on the organization's culture so that, careless behavior or whatever you want to call it is not accepted. There is another old saying, the standard you get in safety is the standard you walk past. So ultimately it comes to the leadership to set the right culture so that, if you like, people do the right thing even when they're not being watched, and then you have the right culture, and then you achieve a good safety performance. That's what I would say.
Yeah.
Great, thank you very much. That was a really good answer. And I think we're actually coming to the end of our time for this webinar. So I will now draw it to a close, if that's okay with our panel members. So I'd just like to say a huge thank you to John, Richard and Malcolm for joining us today. I think it was a really engaging webinar, and also thank you very much to the audience for joining us as well. There's a webinar coming up in November on a similar topic, so we hope to see you there. Thank you.
Thank you.